Okay, this is our ellipses and hyperbolas classwork. I'm sorry I'm not present today, but my son here is not doing well, so I have to stick around. Ellipses and hyperbolas. Number one, an ellipse is this right here. It's not a perfect circle. It's not a parabola, and it's not a hyperbola. Of course, it's not a line, but it's going to be this shape. So we need to find a center, and then we need to find the minor and major axes points, which is not too bad for this. So the center is going to be the distance from x and the distance from y, reversed, or in other words, the general formula. Let me just show you from Alex, actually. Oh, thank you. General formula for your horizontal major axis and a vertical major axis. If your depends on which number is bigger on the bottom here. The bigger number is always going to be the major axis, and the smaller number is going to be the minor axis. So if your denominator is bigger, that's going to be the major axis. But it doesn't matter too much. You can see it's x minus h squared and y minus k squared for both, so that makes it a little bit easier. So x minus h squared, this is going to be my h, this is going to be my k. Obviously it's the flipped versions, just like in a circle. So my center is going to be at 2, and there's nothing being subtracted there, so it's 0. But you do want to flip those signs. So I'm going to set my point at 2, 0, and then my major axis is y, vertical, and it's going to be the square root of 16, which is 4. So I'm going to go up 1, 2, 3, 4. That's going to be that vertex, and then from the center again, I'm going to do the square root of 9, which is 3. I'm going to go 1, 2, 3, and I'm going to get this ellipse like that, which is going to go around something like that. Let me show you on Alex. We just place that center at, choosing the ellipse, center at 2, 0. I'm going to go up 4, 1, 2, 3, 4, and then I'm going to go 1, 2, 3 to the right, and I am done. Go into number. Okay, so you'll notice on number 2, it's not, these aren't fractions, and this is not set equal to 1. For an ellipse and hyperbolas, it needs to be equal to 1. Okay? Not like a circle or a parabola. Ellipses and hyperbolas should always be equal to 1. So I need to divide by this number on both sides and get my full function here. So this is going to be x squared over 16 plus 4 over 16 can be reduced to 1y squared over 4, and that equals 1. So now I can graph this because I have it in the standard form of an ellipse. My center is going to be 0, 0, because I'm not subtracting anything from my x or y squared. I'm going to be starting here, and I'm going to have an x distance of 4, square root of 16. It's going to be there, and a y distance of 2. It's going to be there. There's my ellipse. I can put it into Alex real quick. Oops. Use the ellipse, center 0. This is going to be 4. This is going to be 2, and we're good to go. Let's move to number 3. Number 3, it's well out of order, so we've got to do quite a bit to get it back into order. We're just going to rearrange these so that the x's are all together, the y's are all together, and this c term, or this constant, is going to be moved over to the other side. In other words, I'm going to subtract 525 from both sides. And I get 4x squared plus 25y squared minus 250y equals negative 525. On this, we're going to have to complete the square for at least one of them. The 4x squared doesn't have another x term, so it's just going to be 4 times x squared. I do want to factor out the 4 and think of it as separate, though. And then this y squared and y, I do have a common factor of 25 plus 25 y squared minus 10y, still equal to negative 525. Okay, don't need to complete the square there. There's nothing there, but I do need to complete the square here. So I'm going to add half of this squared, half of 10, 5. 5 squared is 25. So I'm going to be adding 25, but it is also being multiplied times 25. 25 times 25 is 625. So I'm basically adding 625 to both sides. That gives me 4 times x squared plus 25 times y squared minus 25. Y squared minus 10y plus 25 in parentheses equals 625 minus 525 is 100. Okay, now I'm going to divide both sides by 100, and I'm going to rewrite this trinomial as a perfect square. So 4 divided by 100 is going to be 1 over 25, or x squared over 25. And then 25 over 100 is going to be 1 over 4. So I'm going to be 1 over 4, and I said I'm going to rewrite this as a perfect square. This is going to be y minus 5 squared. Y minus 5 to y minus 5 is the same thing as y squared minus 10y plus 25. And now we're equal to 1, so this is the standard form of an ellipse. We've got 4 different things going on: parabolas, circles, ellipses, and hyperbolas. Don't forget lines and graphing rationals. There are lots of functions in algebra. So my center is going to be 0, 5, gotten from here and here. And my x vertex is going to be 5, y vertex is going to be 2. 0, 5, x vertex is 5, y vertex is 2. And that's going to be my ellipse. 0, 5, I'm going to go out to 5 here, go up to here, and we're good. Not so bad so far. Okay, on the next problem, we're trying to find the focus. I should show the directions real quick. Find the focus of the ellipse. So we need to get it in standard form to be able to find the focus. The focus is going to be a distance away from the center. So we need to find the center, and then we need to find the distance away from the center that we're going, which is, let me show you on Alex. So we get it into standard form here. We get the center is -3, 0. That's what they get here. Now we need to know this formula here. For the foci from the center, we need to know that c squared is a squared minus b squared. If you want to know why, you can look at how they derive it. I'm not going to explain that. It is interesting, but we don't have enough time to go over the derivation of everything. So just accept that this is true, and you need to use that to find the foci. And the foci are always going to be on the major axis. So it's going to depend on which number is bigger, right? So in mine, 25 is bigger than 9, so it's going to be on, or this example, I shouldn't say mine. This example, this would be on y, and we have to use this formula, c squared equals a squared minus b squared. C squared is going to be, where did we get, oh, we're just going to take the a squared minus the b squared. So the a squared is always the bigger number, and it is squared, minus the smaller number. So 25 minus 9, which equals 16, that is c squared, and we square root it, and we get 4. Let's go back to my example here. Sketch. Let's get it into standard form first. So first, I'm going to add the 63 to both sides. And I'm going to get 16x squared, no other x, plus 9y squared plus 54y equals 63. Now I got to complete the square. For x, it doesn't look like I need to, because it's just got one term. But for the y, I have 2 terms, so I'm going to have to factor out the 9, and I get y squared plus 6y. Got to complete that square and add that amount to both sides. So I'm going to add half of 6 is 3, squared is 9, which is actually the same as adding 81 because I'm multiplying everything in here by 9. So I'm adding 81 basically to both sides. Now I'll rewrite that. 16 times x squared plus 9 times y squared plus 6y plus 9 equals, this is going to be 144. Now I'm going to divide by 144 on both sides. 144 is also 9 times 16. Usually when you have the parabolas, they're going to make up nice even numbers for us because decimals are a pain. Fractions are a pain. Okay, so now when I rewrite this, I'm going to write this in the complete square form and the reduced fractions. This is going to be x squared over 9. Thank you, Keo. X squared over 9. And this is going to be y plus 3 squared over 16 plus equals 1. In standard form here. Now I know my center is 0, negative 3. Take the h and the k, always switching the signs. And my major axis is going to be this 16 because it's larger. So it's going to be the major axis, and that's where the foci are for an ellipse. Remember that formula, c squared equals a squared minus b squared. And to figure out c squared, we're going to take my a squared, which is 16, and we're going to subtract my b squared, which is 9. A squared is always the bigger one with ellipses. Equals c squared. 16 minus 9 is going to be 7. C squared equals 7. C then is equal to the square root of 7. Now, because my major axis is on the y coordinate, it means I'm going vertically. And if I'm changing, or if my foci are on the vertical axes, that means I'm changing the y value. These are xy coordinates. So I need to add and subtract the square root of 7 to my y value. If your major axis is on the x value, then you can add and subtract it to the x coordinate. But I'm basically going to have 0, negative 3 plus negative square root of 7, 0, negative 3 minus square root of 7. Let's go ahead and do that. Hi, buddy. Oh, hugs. Thank you. Negative 3 plus the square root of 7. I love you. Negative 3 minus the square root of 7. There we go. Moving on. On number 5, we need to find the equation of an ellipse. And we need to know our equations. There's an equation for parabolas, there's equations for circles, there's equations for hyperbolas, and on the later problem we're going to have to decide what something is based on its equation. But this one, we know it's an ellipse, so it has to be x minus h squared over a squared or b squared, and y minus k squared over a squared or b squared, depending on which one's bigger. So it has an ellipse. This ellipse has a center of negative 4, 5. I always like to visualize, so I'm going to just draw that out here. Negative 4, 5. There's the center. Okay, so from here we're going to have a major and a minor axis. The minor axis, which is the entire axis all the way from this point to this point, is 10. So we're only going to go half that distance each way. I'm going to go 5 this way, 5 units that way. So from negative 4, if I go 5 units this way, it's going to be right here at 1. Guess I shouldn't have put that so far out. And from negative 4, 5 units this way would be 1, 2, 3, 4, 5, negative 9. So negative 9, 5, and this is 1, 5. That's the minor axis. The major axis is where the vertices are and the focus. So the vertex is at negative 4, negative 7. So this is at negative 4, 5. It's my center. So to go to the major axis, I'm going negative 4, negative 7. 1, 2, 3, 4, 5, 6, 7. Negative 4, negative 7. How far away is that from my center? Well, if I'm going -4, 5 to -4, 7, that's the distance between +5 and -7, which is a distance of 12. So this right here is 12, and this right here is 5. So I know that my y change, or my y value, is bigger, so that's going to be the a squared. So here's my formula, x minus h squared over b squared, because I know that's the smaller distance, plus y minus k squared over a squared equals 1. The center is pretty easy. I'm just going to plug in -4, -5, -4 for that, +5 for that. And then my a squared is going to be 12 squared, which is 144. My b squared is going to be 5 squared, which is 25. So I'm going to have x plus 4 squared over 25 plus y minus 5 squared over 144 equals 1. Let's just go ahead and plug that in and make sure we are correct. 4, -5. These are kind of a pain to type in. X minus 4. Is it -4 or +4? +4, darn it. Squared over 25 plus y minus 5 squared over 144. Don't forget the equals 1. I do that so many times. It's very annoying. Don't forget the equals 1. You might as well copy this in your thing, because you're going to be writing some of these equations up, because it's nice to have it set up so all you have to do is change the values. Let's make sure it's right. Okay, good. All right, number 6, we're r to the hyperbolas. So let me show you those formulas in Alex. Much easier to show you there. But this is, instead of having our x minus h squared plus y minus k squared, we're going to be subtracting either the x squared or the y squared. If it's x minus y squared or x minus h squared minus y minus k squared, then that's going to be a horizontal transverse axis. In other words, the graph is going to have these two weird looking curves that are symmetrically horizontal. And if it's the y squared minus the x squared, then it's going to have that vertical transverse axis where we're going to have our curves being vertically symmetrical. Notice that a squared is always first in hyperbolas, and b squared is always second, no matter their value. And we also have the foci now are going to have this formula, c squared equals a squared plus b squared, which is what we would expect from the Pythagorean theorem. Don't need to worry about the asymptotes on this. Luckily, Alex kind of gives you that, so you don't have to do it. But these are the two general formula. You need to figure out which one's being subtracted so you can figure out which is the transverse axis or the vertical axis. Okay, so let's look at our problem here. I've got y minus x squared, so that means it is going to be vertical. That means I'm going to have these ellipses like that, or excuse me, hyperbola like that. If it's the other way around, then they would be going horizontally, but it's not. So this is what it's going to look like here, and you can see that nothing is being subtracted here from x or h, so that means my center is at 0, 0. I'm going to have a center, 0, 0. Okay, my y is going to be the distance I'm traveling vertically. And when you do this on Alex, you need to go the direction of the major axis first. If you don't, it won't create the vertical hyperbola. It'll create a horizontal, which is not true for this. We have to do this part first, and it's going to be the square root of 9, which is 3. So I'm going to go up 3, 1, 2, 3 here. That's where I'm going to set my first point. And then, once that's set, I'm going to go to this distance for x, which is the square root of 4 or 2. It's going to be over here. So I'm going to use the hyperbola here. I'm just going to place my center at 0, 0. From there, I'm going to set my next point at 3. And then from there, I'm going to go over 2. Alex kind of makes it easy on you. It doesn't seem easy, but it could be a lot worse without Alex. Okay. So there's my center there. I'm going to go up 1, 2, 3. There's my vertex. I'm going to go here for the asymptote, and Alex graphs the rest for you. Makes it a lot easier. Okay, moving on to number 7. Number 7, we're graphing the hyperbola again, but you can see that it is not in standard form. It's equal to 36, so we need to divide by 36 so it's equal to 1. Get it into standard form. It is an x minus y squared, so it is going to be a horizontal transverse axis. We've got x squared over 36 minus y squared over 1. 36 divided by 36 is 1. And now we're equal to 1. My h and k are 0, 0. I'm starting at 0, 0. Okay? And I do have a horizontal transverse axis, so I do need to go the square root of 36 first, which is 6. I'm going to go this distance to find the vertex, and then I'm just going to go up or down 1 for that asymptote. Let's go right over to Alex. Here's 0, 0. Be careful because it does go by halves when you're placing it, so you got to be careful. Oh, this one is not going by halves. That's nice. So I go over 6, and then I'm just going to go up 1, or you could go down 1. And that should be correct. There we go. I'm going to stop this video here so that it's not such a long one, and we'll do the second half in part 2.